before I get started with that, I want to talk to you about who I am, so that way that puts everything into context. And my name is Heather, as I said, and I would describe my time at T-Mobile as almost 100% focused on prototyping. And so I am a machine learning engineer. I joined T-Mobile in 2017, and I was a founding member of our T-Mobile AI team. And that AI team was actually started with a 12-week prototype with just 3 engineers on task. And so from a prototype, we are now a team with almost 100 people in our larger organization that are underneath all building and deploying these smart applications. So it started with a prototype and is now a huge enterprise staple. And I used to want to be a neuroscientist, and I wanted to get my PhD in neuroscience, but I was doing a study where I had to collect data from rats for a year. And at the end of my study, I was very excited. I took my results to my primary investigator, all of my data, and she said, "You can hand that off to the analytics team now." And I almost exploded because I was like, they don't know my rats, they don't know my data, who are these people? I would rather go out and become qualified to analyze data myself. And that's when I learned I like data science and machine learning much more than neuroscience, and I pivoted from real brains to artificial intelligence. And I'm also incredibly active on Twitter, and so if you have any questions at any point, you can always just @ me, and I will probably get back to you. And so, like I said, I am the AI team at T-Mobile. Well, I help lead the AI team. And our primary scope is customer care. And so what I mean then is anytime, if you're a T-Mobile customer and you pick up your phone to call us about an issue or a question that you have, if you're DMing with us on Twitter or Facebook or even clicking around in the app and using some sort of chat interaction, that is the data that my team uses. That's our bread and butter. And we're really focused on building AI that helps that contact center expert solve your problem more quickly. We know people have various feelings about bots. Some people really love them, some people don't. And so the majority of our efforts is focused on not AI for the customer, but for AI for our actual contact center experts solving problems. And this is our flagship project, just to kind of give you an idea of what we do. You might have somebody come in and they're on the phone call and they say, "I want to pay my bill without a fee, but I forgot how." And in the few seconds that it takes the contact center expert to get that information together, we want to be able to provide as much information as possible instantly to try and help them solve their problem. And we do this currently over 2 million times a day and growing. By the end of 2023, it'll be over 20 million times a day, so we're growing like very fast with how rapidly this is scaling. And you might look at this and you might say, well, where's the artificial intelligence inside of that? Well, we have an in-house neural network that determines what are the customers actually coming in and talking to us about. We have recommended responses that aren't corporate jargon. It's actual responses that these experts say all the time or have written out that we recommend would be useful here. We also do some quick facts where we just grab, like, knowing what we know about this user's account, are there any pieces of data that are relevant to solving the problem? And then we do an information retrieval on our giant internal Wikipedia to say, do we have any articles to solve this problem in case the expert who gets it doesn't know how? And then finally, we have a memo section that automatically writes the memo of the call. So why did the customer come in? What major system attributes were changed during that time? So did we pay a bill? What sort of system memos can we put in there as well? And every single one of these features required a prototype. So the whole team was spent off actually, our first prototype was just a topic model based on the first message a customer sent us, and it was, could we do that? And every other piece that you see here has been developed and just kind of hung off of that, but always prototype first. And so let's say that you have the perfect idea. And by that, I mean you've done your market research, you know that it's something that will actually help users, it's in line with your business case, and you know that your technology will work. And those things have to be true before anything I'm talking about today will be meaningful. So if you haven't done those things, always start there. But let's say that you have that point and you're ready to start building a prototype. How can you do it in a way where you understand that eventually you want this prototype to be enterprise and delightful with the least amount of rework possible, but also quickest value to give executives what they need to buy into your idea? And before we do that, I want to kind of classify some jargon because I think that these words are used interchangeably. And I think that for some people they are interchangeable. I use them slightly different. So when I say POC, what I mean is that is almost a proof of technology. It is, what is the smallest thing that me or someone on my team could do to prove that my idea could even work? So that involves making sure that the data that we think exist actually exist, making sure that it contains the signals that we want, and maybe even a first draft of a model, maybe even some sort of demo GUI to put on front of that model. But that's different than an MVP, because an MVP is something that is live in production. That is your minimal viable product. And it's the smallest functional unit that a user can actually interact with. And so from a data science perspective, moving from a POC to an MVP might not be a ton of work. You might have your model created, there might be some fine tuning, and the MVP is sometimes software lift. How do you get that integrated into your giant system? And I kind of have this law of POC maturation of just what I've observed in my time on a prototype first team, which is almost all POCs will become MVPs that are live in production, and all of those MVPs will remain minimal and viable until impacted by some outside force. And that outside force might be a KPI is super good, so an executive says, yes, this experiment is successful, we'd love to invest. It could also be that a KPI is bad, so they want to turn it off. It could be a requirement change. It could be some sort of business priority where they say, this is a great experiment, but we don't want to invest in that for 6 or 7 months. So hold off on it, funding, or very rarely a previously determined end date, which is strange because you think if a product is minimally viable, you'd want to get it to fully fleshed out and delightfully viable as soon as possible. But in general, people tend to think if it works, let's not touch it. The issue that I find is the definition of minimal is normally defined by software engineers. And so what I see from a data perspective is as these minimal viable products are continued to exist in production, if you haven't done due diligence of setting them up nicely, your tech debt increases, and it becomes more and more difficult to touch them later and fully flesh them out. And so I'm gonna kind of go over my recipe for prototype success on my team, which again, like, assuming you have a perfect product that perfectly answers every perfect business need perfectly. There are really, from my perspective as a technical team, only 3 areas that I can control. I can control staffing, who is at the table, who is on my project. I can control the scope of my project, what is minimal, and how do we define that? And then I can also determine the workflow, how we're gonna actually interact. And for me, the number one thing that is important is for an MVP that is going to be live in production, I want a fully stacked team. And that means I need product people, I need designers, I need software developers, and I need data scientists. And I need them to be involved from the very, very first minute across all of those verticals. And my goal here really is to avoid the roadblocks that might come up during my path to production, and just to make sure that the groundwork is absolutely laid for all of these 4 different types of business people who interact with the product. And so you might say, what do these different people look like? This is my full stack team menu. So you have your data people, your product people, design and software. And the idea is that you really need every single person from the second that you have an idea to actually getting it deployed to supporting it in production involved in this MVP, or it will not become an enterprise standard because it will roll along in half work until tech debt piles up and you say, okay, it's not good anymore. The second piece that to me is incredibly important for MVP is scope. And I kind of mentioned this earlier, which is minimal to who? I think there's a strong tendency for business people to say minimal to the business, and there's a strong tendency for software engineers to say minimal for software engineers. So for instance, the number of times a software engineer has told me that we don't need telemetry, it's just a POC or an MVP, we don't need to store data, is immense. But for me, as a data scientist, as a machine learning engineer, I need telemetry because I need model logs I need the input logged, I need the output logged, and I need any features logged that will allow me to iterate on my model later. You can say, but it's a minimal viable product. Why are you storing these things for future scope? Because we assume any MVP will actually be left on unless we've determined a predetermined end date. And so then I need that information that will help me actually iterate my model, and we might not get the permission later for software engineers to go back and touch that code. So I need to be intimately involved, and so that's when models make predictions, that needs to be stored. It needs to be stored alongside the features that allowed it to make those predictions, and then data scientists need to be able to evaluate it and iterate. Even if we aren't doing that yet, you can't go back in time and recreate all the data that you didn't store. And what ends up happening is you end up having to take the data that is like what your model would be doing and pay a data labeling team to label it. And so in the interest of keeping costs down, by having just an engineer write 2 or 3 lines of logs, it can save you having to spin up an entire data labeling ecosystem later to solve this problem again. And then the final part, which to me maybe is the most important, is that you need agile design. People tend to think of design as a phase of a project that happens initially, but I think that this is a fundamental malpractice in the data world. And that's because prototypes are built on an idea, and ideas contain a ton of assumptions. And it is so easy for a designer or somebody who doesn't work with data every day to make assumptions about what data science can do and what models can do. You don't know what you don't know, and being agile requires adapting to change. And so you need to make sure that design is constantly in the loop, and your data scientist and your designer should kind of be best friends. And so I won't read every single piece of this, but you are welcome to, and this is just an example of how the design and data cycle works on our chatbot team. So if somebody has the idea, let's add a feature. That idea could come from a data scientist who has been looking in the data and saw a very clear win. It could be from a conversational designer who's been reviewing entire conversations and sees a systematic problem. Or it could be from a product person who is paid to come up with these sorts of ideas. The first thing that we do is we have the data scientists pull it and say, is this even happening enough? Sometimes product people have an idea of something that might be a really big problem, but the volume is 0.0001% and it's not worth investing in. And then the data scientist takes that data and it provides a sample of it to the designer, so that way the designer can do a data-based design. And the data scientist and the designer enter in this sort of feedback loop with each other, where the data scientist will show a design and the data scientist gets to say, is that technically feasible? Is it something that I could do? Are there ways that we could design it better? For instance, with intents, always, in my situation, it's, you think I can create an intent that's that specific, but natural language cannot get that specific. I will always be catching other types of categories, so maybe we do a disambiguation block instead and allow users to self-select. After data science and design have hammered that out and are in consensus, then we show it to product. And then product gets to put the business flash on it. And then our stakeholders get to approve it. And after they do that, then we show it to engineers for technical feasibility. And what is really important to this cycle is that data scientists who are in the data need to be constantly suggesting features, and product owes data science the ability to prioritize those features and take their input as pretty serious. And by doing this, you can make sure that you have a product that you're building fast that's actually addressing a customer need. And so specifically on our chatbot project, where we do this sort of cycle constantly, our ROI is the highest of any AI project that I've ever been on, so it's over 700%, which is absolutely incredible, and it's because of this tight link between data-informed design. And so, in short, to truly have a successful rolling POC is kind of what we call them, because it's going to start on your laptop, but it's going to roll up into production and become enterprise standard. You need to make sure that all the teams necessary to go to production are involved. It can be really scary, and it can feel like you're bringing too many people to the table, but in a lot of these applications, for instance, if some people are building a software application and they think that later they might want to make it smart, we include a data scientist just to check off on their logs and say, this looks great. So it doesn't have to take a ton of time to involve people. There's also making sure that you save all the data that you need to iterate. The number of times that we've released a POC and then realized that we actually had click data that would have been a beautiful semi-supervised data set, but we just didn't store those clicks is immense. And then also just make sure that you're iterating your design alongside of the software and not leaving design as a phase that's done and completed, that's prescripting exactly what your technology should do. And that's all I have today. Thank you.